We're now going to perform some calculations with hydronium and determine the pH, the hydroxide, and the pOH. Let's first start with pH. Remember that pH is the negative log of the hydronium concentration, and that's what we're given right here. So that's going to be the negative log of 2.5 times 10 to the minus fifth. Now, before we do this, is that going to be acidic or is it going to be basic? In my calculator, I have a plus minus button. I'm going to push log, and then you could, and then negative, and then log, and then you could go ahead and put that number in that way, or you could put it in that way. Take a moment to do that. Okay, what it turns out to be is, when we take the negative log of 2.5 times 10 to the minus fifth, we get 4.60. Now that might look to you like the wrong number of sig figs, but actually it's correct. If we were to count this number and these two numbers as significant, you'd get 3. And that's what we have here. Another way of looking at it is the numbers after the decimal point should match the number of significant digits before the power of 10. Either way, we come out with the same number of significant digits. Furthermore, you should notice that this is below 7, so it would be acidic. Okay, let's do an easy one. How would we figure out pOH? Well, remember that pH plus pOH always equals 14. So pOH is going to equal 14 minus 4.60. Put that in your calculator. Okay, so your calculator then says 9.4. The problem is that's not the right number of significant digits. We need one more. So we're going to add a 0. Again, we want the same number of digits after the decimal point. So far we've been able to calculate the pH and the pOH. Now let's calculate the hydroxide concentration. Remember that hydronium times hydroxide always equals 10 to the minus 14. So hydroxide is going to equal 10 to the minus 14 divided by the hydronium concentration. In this case, 10 to the minus 14 over 2.5 times 10 to the minus fifth is going to be our hydroxide concentration. Take a moment and put that in your calculator. So 10 to the minus 14 divided by 2.5 times 10 to the minus fifth equals 4 times 10 to the minus 10th. That's going to be our pOH. Is that the right number of significant digits? Well, actually, if we look here, we have 2. This 4 would correspond to that 10 to the minus 5. So we need to add 2 zeros. Those 2 zeros are what correspond to the 2.5. In our next video, we're going to find the hydronium hydroxide pH and pOH if we start with the pH.